Hi everyone, my name is Adam Volk. I'm a Principal Technical Program Manager for PostgreSQL here at Microsoft. Today I'm going to tell you how to travel using row-level security with PostgreSQL and Citus. So grab a towel and join me if you want to learn how to use row-level security with your application. Hi everybody, don't panic. We're going to learn about row-level security in PostgreSQL and in Citus today. So just like a towel, row-level security is a useful tool. Imagine you're on a beach and you need to cover some private parts. Then, if you have a large enough towel that's just right, it will do its job. It will hide the pieces that you need covered, and same with row-level security. Things that need to be hidden will be hidden. If you wrap yourself too tightly, then you will be encumbered in some way, and with too complex policies that you employ in PostgreSQL will slow down your database. Won't be able to move as fast as it used to. You can have a too small towel, and then it will cover too little. People from the side will be able to get a glance on things that they shouldn't see or infer what's there. And it can be too big, essentially covering you wholly, and then somebody will step on you because they don't know that you're sunbathing underneath a towel. And the same can happen with pro-level security. If you cover everything and want to do a backup, and then all the rows are hidden, then you don't have a backup. So we're going to touch upon some of those aspects also. So you can think of row-level security the same way as a SEP field. So as soon as you enable it and have some policies in place, it will the rows that are under the policy become somebody else's problem. You will no longer see them, or they will no longer see them. Now, uh, there's some cases where somebody can see through the SEP field, through the row level security. If you're an owner of a table, you're exempt from the row level security policies, and you can see all rows. You can change that with the force setting. So if you tell alter table force row level security, even you as the owner will be uh, forced to obey the policies. Now, some other users essentially bypass it. Anyone with a bypass RLS row level security role will be able to bypass it. Also, the super user will be able to bypass it. And there are some mechanisms of PostgreSQL that simply ignore it. For example, the truncate command or any foreign key references, but they need to do it to uh, provide integrity, essentially. And there are some leak-proof functions that can leak data that we may touch upon later. So defining row-level security policies, that's something like every wagon's bureaucratic dream to define policies. By default, the policies are ignored. Like if you create a policy and don't enable row-level security, it's just there. Uh, you define a policy per table, so every table can have its own set of policies. You can reuse the name across different tables, but obviously unique on the same table. There are two types of policies you can have: permissive and restrictive. By default, if you have no policies, it's deny all. Permissive policies are required to say you can access a row, and you need at least one permissive policy evaluating to true to see any rows at all. And if you have multiple permissive policies, they will be chained together with an OR clause. So if you have 5 permissive policies defined, you need just one of them to evaluate to true to be able to see a row. Now, if you have restrictive policies, they are the opposite of that. They tell you for whatever you are allowed to see, remove, make sure that we don't need to remove more. Right? So they restrict what you were allowed to see. And they are chained with an AND clause. So if you have 5 restrictive policies, all of them need to pass for you to see the row. And if any one of them doesn't pass, then you're not allowed to see it. To see any rows at all, you need at least one permissive policy passing and all restrictive policies passing. There's no point in having just restrictive policies, so you always need at least one permissive. Now, policies can be defined for all commands, a subset of them. Like you can decide, well, I want a policy for a select and a delete, but I don't care about insert and update. Or you can define them for a single one of them, however you want. Policies can also be defined for everybody in the database. So for the public role, which is the default, or for a specific role user, whatever you define. Now there are two clauses that takes expressions. So you have a using expression, which essentially applies to existing data. So it would apply to select, update, and delete because they work with existing data. And the with check would be used for the newly added data, like an insert statement. It gets tricky with the merge command because it will apply to a mix of both, right? If you're doing a merge command that can result in an insert or update or an upsert or something like that, or a delete, merge with delete, then it will use the appropriate policies and appropriate types of commands that were defined for it. If you don't provide a with check, it will use the using clause that you define. So if you skip this with check, it will use the using clause both for newly added and existing groups. Now there's also this GAC. GAC is like a user configurable variable in PostgreSQL uh, called row security. That's very misleading, and it tells you like you can set it to off, and what it does is it doesn't disable pro level security. What it does is it tells you if I run a query now, would this query be limited by the policies of row level security? And you can see here we have a table literature entries. Uh, we select from it and we see two books by Douglas Adams, and we turn uh, row security to off and do the same query again. And now we get an error that, hey, this query would be affected by row level security policy for table, blah, blah. Now, maybe you see a gap between 1 and 3. So, and it says that there are two rows. We don't know if there are two rows, but maybe there's more. Maybe some policy hides that row from us. This is useful for the too big table example. Like if you're doing backups, you want to make sure that you exported all rows. So knowing that something would be hidden is useful. And this is actually something that pgdump is doing when it's doing an export to make sure that you're not tripping over your own towel. Okay, so that's row level security with PostgreSQL itself. Now with Citus, Citus is kind of cool. Citus brings some alien technology back to PostgreSQL so that you can get your standard PostgreSQL database and expand it horizontally across multiple machines, just like a Galaxy expands. And you can do it by schema or by row, and we will focus by row in this specific presentation. So think of sharding as in like partitioning. So imagine you're taking a table and deciding I'm going to take a column of this table and designate it as the distribution column. So I'm going to split the table based on the values of that column. And that way you end up with many small tables. Let's call them shards. The magic in Citus is that it allows you to move shards to a different machine, and all machines in the cluster know where every shard is. So if you ask any machine about any data, it knows where to go to get that data back to you. So because I'm lazy and I have it handy, I'm going to use Elastic Clusters, which is essentially Citus available on Azure Database for PostgreSQL Flexible Server. And it's the standard Citus that you can use and deploy yourself. What it does actually is like the difference is that we added this special port 7432, which actually load balances any connection that you may make to any node in the cluster, and that way you can scale your workloads by splitting up the incoming traffic onto many nodes and have every one of them act as the single like as a coordinator node essentially. So imagine that in the bustling data hubs of the galaxy, there's this pan-galactic biblioteca that maintains a table called like literatural entries that we saw before to store books, poems, and other like countless creations. So this is the table. It's very basic, but we also know that some of these will be the dreaded works of Vogon poetry, and these can cause distress to anyone who read them. So it would be nice to have some form of preventing people from accidentally reading Vogon poetry. So we add a content rating, and this odd to small lump of green putty is abstracted part of a Vogon poem that we want to prevent people from seeing. So we will have 5 as the content rating for any non-Vogon poetry, and Vogon poetry essentially for Vogon poetry. Next up, our prosthetic Yields Jr., the author of the database, a well-meaning but slightly careless DBA, will try to define some roles and policies on how to access this table. So we can see a critic role, a Vagon bureaucrat role. These roles are no logging, they are used for grouping permissions, and we create a very simple policy on the table allowing you to read safe poetry, and a policy for Vagon bureaucrats allowing them to read everything if they want to. And of course, we enable row level security. Prosthetic Guilds made a mistake of not doing force row level security. So, as the table owner, when he tested this and ran select start from table, he was exposed to the full length of the Vogon poetry and ended up uh, essentially hospitalized for the remaining time. So, please remember to apply policies. So, row level security with Citus itself is the same as with PostgreSQL. There's really not much different because Citus it is magical in a way that you can do almost anything that you can do with Postgres. But there are some good practices that you can do when using row level security with Citus itself. The first thing is there are two ways you can set up policies. One way is to use role-based policies, let's call them that. So you can see here, I have a example based on like the standard Citus tutorial with companies, ads, and campaigns, and I'm trying to limit every tenant of the table to access its own rows. So I'm defining a policy on every table that's for all commands, and I'm allowing the current user to execute that command only uh, their uh, if their user name, the PostgreSQL role, matches what's stored in the ID column or company ID column, because this data is distributed based on company ID, essentially. Uh, this is nice because it limits access down to protocol level. Like you connect with the user, you have access or not, and there is not much you can do about it in terms of swapping tenants. The problem with this is overhead, like you're adding a lot of users to your database, so that may be cumbersome. And the other problem with that is you have more connections overhead because you cannot multiplex a single connection onto multiple tenants. But that is very useful when you, for example, have an application and want to give a tenant direct database access to your system so that they can do ad hoc queries without the risk of them snooping around on other tenants. Another approach common for doing row level security with Citus would be a set local based policies. So you can use PostgreSQL settings and introduce a custom setting like my application.company ID and set the company ID to the tenant that's going to use the database. And here, everything is the same except that we're reading the current setting of this value and comparing it with the company ID. So querying that data with setLocal setup is very simple. First, in your connection, you need to enable propagate set commands to local so that local commands are propagated. Then you open a transaction. Within that transaction, you set local variable company ID equals 5. And then you can do a query for that company ID. And you should be able to see those rows. But if you try to query for a different row, that row won't be visible. Like if you tried company ID 6 with this value being set to 5. There's a gotcha with Citus before version 13.1. In version before 13.1, if you're doing grant permissions with this with inherit option or with set option, these won't be propagated to all nodes in the cluster. That changes with Citus 13.1. But in previous versions, if you want to use something like this to essentially assign rows, you will need to disable DDL propagation and use the run command on all nodes to essentially execute this command on every node in the cluster. That's just an easy way to do this. Okay, so now that we've got all the theory out of the way, we can actually jump into seeing both things in action. So we will going to do the Vogon poetry example, and we will do the row level security setup with the campaign stable for Citus. So let's swap to a friendly PostgreSQL terminal, and I'm here connected actually. I can connect here to my remote cluster running Citus on a 2-node machine. Let's swap display so that it's better visible. So you can see like I have 2 nodes, this node on port 7000 and this node on port 7001. And I took the leisure of creating some tables. So ads, campaigns, companies, literature entries, and even reviews. And what we are going to do is, first off, we are going to just select from this table, from literature. So we can see all the 3 rows, including the Vogon poetry row. And this is because we haven't enabled row level security yet, and we haven't defined any roles. So if we connect to this database, for example, not as me, but as Arthur, we can also see that Arthur is able to query the whole table. So if we swap the display, we can see he unfortunately can see Vogon poetry, and we don't want that to happen. So let's connect back. Let's enable low level security on this table. And if you look at it right now, you will see that the policies are enabled, and that should change how things work already. So let's connect back as Arthur. Let's filter and do a query. We can see that we have no rows because by default with no policies, nobody can access anything. So let's define some policies. So I'm going to execute create policy that we saw in the slide deck. This creates 2 policies. You can review them on the table. Policy for select save, and policy for Vogon access for Vogon bureaucrat to do everything. If we connect now as Arthur and try to read from this table, we still have no roles because we didn't assign any role to Arthur himself. If we go to our my super user account and check what role assignments I did, you can see that Zapot is a critic, Marvin the robot is a Vogon bureaucrat because, hey, robots don't care about reading Vogon poetry. But just for the sake of it, we prevent Arthur, the regular human being, from reading anything stored there because maybe he sees that Earth is bound to be destroyed in 50 years and maybe files a complaint, and the Vogons wouldn't be happy about that. So what can we do here? Let's connect as Zapot and see the same table, we can now see that, and I'm going to swap displays, we can now see that the Vaughan poetry is hidden properly. So the rule that we defined is fine. And if we connect as the Marvin robot and execute the same query, we can see the additional Vaughan poetry being shown. Now, but Zapad is a very curious fellow, and he noticed that there's this reviews table that doesn't have row level security, but has a foreign key reference to to the entries table that stores all the data here. So the question is, can I insert into reviews where, and I need to select so that I have some, yes. So can we add a review for the first entry in the books table? But good book. I can, if I write without errors, which is reviews. Sorry. So I was able to add a review for the first entry in the books table. I can add it for the second. I can add it for the third book. And I cannot add it for the fourth book. So what happens here? If we select Zapad from the entries here, we only see 2 entries, but we were allowed to do more. We were allowed to insert the second row. So knowing this, we just figured out, okay, if I provided an ID that doesn't exist, I would get a foreign key constraint error. I didn't, so entry 2 must exist. And that way Zapad found out that on row 2, there's probably something hidden. Now, this may or may not be a problem. This is like a side channel leak, essentially somebody using the knowledge of something is there to figure out if it's there or not. That may or may not be a problem, but keep that in mind. You can, of course, design around it. You can make sure that you cannot add reviews for rows that you shouldn't see, etc. But just keep in mind when you're designing your security policies, what type of information can be figured out by the act of not seeing everything. Okay, now we can switch to the Citus-based example. So we're still connected to the cluster. Let's make sure that I connect as my super user. We see several tables. Currently, there's no policies in place. So let's enable row level security. So this is very simple. Alter table for every table. Enable row level security. Now we have row level security enabled, but with no policies. So what does that mean? That means that right now I can connect as 10 with 42, and I can do a query like this for company ID 5. And I enabled row level security. So since there's no policies, I see no data, neither for this tenant or for my own tenant. So if I do 42, I still see nothing, right? Now, if we want to fix this, we need to define some rules. So let's define the role-based policies. Policy role-based. We saw it in the slides. This compares the current user to tenant underscore ID of the company. So roles are now created. I did cheat and I created 100 tenant something users beforehand so that you don't have to wait for him to create them now. And of course, in a scripted manner. But let's connect back as the tenant 42 user. And let's try doing this query again. which is, hey, I want to see rows from 10 and 42. And suddenly we can see the data. And this is very bad. But I have a meeting starting right now. Okay. So if I switch to company ID 5, we can no longer see the data because I'm connected as 10 and 42. And if I select from the company's table, all I see from the company's table is 10 and 42. If I reconnect as 10 and 13, the only the only data I will see when querying the company's table is rows for company 13. There's no additional, there's no other way for me to access any other row in these tables because my access is limited by the policy that we defined, that I have to be this user to access these rows. Okay. So let's drop this policy. Typo. This is just drop policy name from the company's tables. And let's define the second policy, which is the set local based policy. So now with this policy in place, if I'm connecting as advertisement user, for example, so not like nothing related to the tenant setup that we had before, and I do a query from companies, it will fail because I didn't define this set local variable. So what I need to do is query set local. First off, we disable the set commands. Then we open a transaction, set my ID to this company ID 5, then do the query. So let's do this. And we can see a lot of results. Now we can try to do this manually. So I'm going to open a transaction, set local my app company ID equals 42, select all from companies, and I see, I'm going to change the display, and I see only record 42. Now if I change the app ID to 13, and I do the query, I can see data for a different tenant. And as you can see, I can reuse the same connection. So from the application's perspective, that's nicer because it's easier to handle this without additional users. But if you're allowing somebody direct access to the terminal, then that's harder to manage and filter off, essentially. So with that, you should be set up for your travel with row level security. Grab your towel and go try it out.